BCHCT 133 Chemical Energetics, Equilibria and Functional Group Organic Chemistry 1, Volume 1, Chemical Energetics and Equilibria, Block 1, Chemical Energetics, Block 2, Chemical and Ionic Equilibrium. Chemical Energetics, Equilibria and Functional Groups Organic Chemistry 1 Introduction. Dear learners, welcome to the core course in chemistry titled Chemical Energetics, Equilibria and Functional Group Organic Chemistry 1. This course is designed as per the CBCS scheme of UGC and is worth 4 credits. It requires an average of about 120 hours of study time at your end. As is evident from the name of the course, it has been designed to cover the content from the domains of physical chemistry as well as organic chemistry. The course content has been divided into a total of 19 units main chapters that are organized into 4 blocks. The first 2 blocks containing 9 units cover the topics of physical chemistry and the remaining 2 blocks cover topics of organic chemistry. In order to facilitate the organization of the course content, it is presented in 2 volumes. The volume 1 contains the first 2 blocks of the course. The first block in the volume is titled Chemical Energetics and contains 4 units 1 to 4 that broadly cover the introductory aspect of chemical energetics, the laws of thermodynamics, their significance and applications. The second block titled Chemical and Ionic Equilibrium contains 5 units 5 to 9 that cover the introduction to chemical equilibrium, its characteristics and detailed account of its application to aqueous solution of acids, bases and salt. The volume 2 contains third and fourth block of the course. The third block of the course contains 5 units 10 to 14 that deal with the preparation, properties and reaction of aromatic compounds and alkyl halides. The fourth blocks of the course also contain 5 units 15 to 19 that deal with the chemistry of the 5 classes of compounds, viz. 1 alcohol, 2 phenol, 3 ether, 4 aliphatic aldehydes and ketones, and 5 aromatic aldehydes and ketones. Objective: after studying the content of this course, you should be able to state and explain the laws of thermodynamics and outline their significance. Explain the concept of internal energy, enthalpy, entropy, and Gibbs energy, outline their significance, and state the relationships between them. Derive mathematical expression for the determination of various thermodynamic properties of different systems under different conditions. Discuss energy changes accompanying chemical reactions and describe their experimental determination. Explain spontaneous and non-spontaneous processes and state the criteria for their spontaneity. Define and calculate absolute entropy for a system and differentiate it from residual entropy. Explain chemical equilibrium and derive an expression for equilibrium constant in terms of Gibbs energy. State Les-Chatelier's principle and explain its application. Describe different theories of acid and bases and discuss their merits and demerits. Define pH and calculate the same for aqueous solution of acid, bases and salts. Describe the stepwise ionizations of diprotic and polyprotic acid and write expressions for the respective ionization constant. Relate the strength of acid and bases with their molecular structure. Define buffer solution, explain their mode of action and calculate their pH. Discuss the preparation, important reactions of benzene and explain the effect of substituents on the reactivity and orientation in benzene ring. Classify and draw structures of simple halogen derivative, alcohols, phenols, ethers, and aldehyde and ketones. List the general methods of preparation of aliphatic and aromatic halogen derivatives, alcohols, phenols, ethers, aliphatic and aromatic aldehydes and ketones, and explain the mechanism of electrophilic substitution reaction, nucleophilic substitution reaction, elimination reaction, and nucleophilic addition reaction.